Hello. Today I will be discussing my favorite and most interesting topics I learned in science this year. First, I will be talking about our ecosystems unit. The topic I found most interesting in this unit was the ways to restore ecosystems. I picked this topic because I find it interesting that humans can repair things that were once originally unlivable and turn it into something where it can house life again. To restore an ecosystem, there are three main ways: reforestation, bioremediation, and bioaugmentation. So, starting off with reforestation. Reforestation is the growing of new plants and trees in an area that has been damaged. Reforestation can happen naturally over time or can be caused by humans placing seeds in the ground. In the photo here, this first one, people can be seen planting seeds so that this forest can eventually regrow and be a thriving ecosystem again. Human reforestation is very important because it is trying to fix places that were most likely destroyed by humans. An example of this is the Amazon forest. There's a picture right here. This place has experienced massive deforestation, which has resulted in almost 20% of its total land lost. People and organizations are trying to regrow the Amazon rainforest, but it's very difficult due to so much land being destroyed. Alrighty, now moving on to bioremediation. Bioremediation is a quite complicated method of extracting toxins that can be found in the contaminated areas. This process of extracting toxins is caused by humans placing plants and fungi into an area that need to be cleaned. On this diagram right here, it shows how bioremediation is being used to repair an area with oil contamination. The bacteria in the photo are breaking down the oil so that one day it can be returned to what it was like before the factory was put there. Besides bacteria, there are many different plants that can use bioremediation, such as this yellow flower here, known as the Indian mustard. It is just one of the types of plants that can it can remove metals from soils. Bioremediation does have its limits, though. As said by Teresa Phillips, bioremediation is most effective when performed on a small scale. The 1986 Chernobyl nuclear disaster, for example, was far too catastrophic to be positively affected by bioremediation efforts and is essentially beyond repair. So what this quotation means is that bioremediation is only effective for small scale contaminated areas. Okay, and then lastly for this section, there's bioaugmentation. Bioaugmentation is often used to add nutrients to depleted soils using plants. In this picture here, in the before picture, you can see how the soils have become depleted because the plant sucked all the nutrients from the earth. In this next photo, the after photo, you can see the result of bioaugmentation being used, how the soils and plants in the photo have nutrients again. Oh, okay, so we're done. Okay, I'm done with ecosystems, and now I'm moving into space. So the topic I chose to do for the space unit was about exoplanets and the ways they are being discovered. I like this topic because I think space exploration is very important to humans. And this ability to discover characteristics about planets outside our solar system absolutely fascinates me. An exoplanet is basically just a planet that is located outside of our solar system, whether it is like the rocky planets of Mars or the gas giant of Jupiter. All exoplanets are different and have different characteristics. Not one is the same. Exoplanets are commonly researched because we can learn so much from them. Like for an example, if there's life on other planets. Although only 4,331 exoplanets have been discovered out of the seemingly vast universe, there's probably still quite a few more to be found. The main way these exoplanets are being discovered is by looking at light from a nearby sun being blocked by an exoplanet. This method is called the transit method. This light curve graph right here can tell someone the size and speed of an exoplanet, and the size and the speed an exoplanet is traveling at by looking. You can see by how fast it's traveling at by how wide the lines are here. The deepness in this here can tell you how big the planet is because it shows the amount of sun being blocked. So the more light being blocked means there's a bigger object in the way. Um, Through scientific techniques like this one, to discover the size and speed of a planet, people have been able to discover planets that could possibly sustain life, such as this planet right here, K2-18b. Because they have found large amounts of water vapor in the atmosphere, in this photo, it shows this is what K2-18b looks like, but we probably won't be able to visit in our lifetime because it's 111 light years away, meaning it would take, traveling at the speed of light, it would take 111 years. In the quotation here by Morgan McFall Johnson, it says, "The hydrogen-rich atmosphere seems to form a dense envelope of gas that would make any life on K2-18b quite different from that on Earth. This means that there is a possibility of life developing here. It would just be different, very different from our own organisms and way of life on Earth." So now moving into electricity. I found how different materials get different charges interesting because I find it intriguing how one material can gain different charges while others cannot. In this section, I will be comparing the differences between conductors and insulators. Conductors are materials that cannot hold onto an excess amount of electrons, so electrons just pass right through them. Most metals are also conductors, and that is why they're used to make wires and circuits and like electrical products, because they allow electrons to flow through. In this photo here, it shows how the wire, this like kind of rectangle square here are the wires, and you can see how it is enabling the electrons to flow it, thus like making the circuit complete. And the most common type of wire used in circuits is copper, mainly because it is quite abundant and it does not have much resistance, so electrons can flow through it without resistance. Also, each conductor has a different amount of how conductive it is. I believe that one of the most conductives is silver, although it's not often used due to its rarity and its price. Insulators are the opposite of conductors. They can hold onto excess electrons because the electrons cannot transfer from atom to atom easily, so charges can be built up. On this electrostatic series here, it shows which materials gain electrons more easily than others. At the bottom of the chart here, which means is the most likely to gain electrons, there's ebonite, and then at the weakest tendency to gain electrons, there's our human skin. Okay. So now going into chemistry. The topic I chose to do was isotopes. I'm interested in this topic because I find it interesting how slight changes in a particular element can massively impact its characteristics. Isotopes are variations of an element because they have one thing different in each one. Each isotope has a different number of neutrons, while the number of protons stay the same. This small detail of a couple more neutrons can drastically change the atom. In this photo, it shows what the 3 different isotopes of hydrogen look like. Each one of them has a slightly different count of neutrons. So here, this one has 0, this one has 1, and then this one has 2 neutrons. So now, because you can't just write the normal hydrogen symbol. There's a thing called the isotope symbol. So in the isotope symbol, you write the element symbol, which in this case, in this photo, it's helium, the mass number, which is the number of protons plus the number of neutrons, and the atomic number, which is the number of protons. So what are some examples of isotopes and like what are their changes? Isotopes can have massively different properties. An example of this could be carbon. Carbon-12 is very commonly found on Earth and is stable, while one of its counterparts, carbon-14, is very radioactive and unstable. It can be found in Earth's atmosphere. This is why I find isotopes very interesting. Between these 2 photos, there's only 2 more neutrons in carbon-14, and it completely changes the atom and makes it radioactive. Okay. So now, finally, here's my most favorite and interesting topic. So overall, my favorite topic throughout science this year was learning about the absorption spectrum in our space unit. I find it very intriguing to know that you can tell the composition of a star based off the colors it absorbs. This spectrum was first discovered by Joseph Ritter von Fraunhofer in 1817. An example of this is on this picture here. Based off the colors it absorbs and emits, you can tell that it is a hydrogen atom. You can also see in the graph that the colors that are being absorbed are the exact same colors as the colors that are being emitted. Because each element absorbs different colors, scientists can use a spectrum to uncover what certain stars and gases are made of. The way the spectrum is absorbed by certain elements is because each color has a different wavelength, and certain elements absorb certain wavelengths. So here at the bottom here is a thing of showing which has the highest versus the lowest. This technology is very important because it can tell us what things are made of, because lots of these places that are being researched are too far away or too dangerous to visit. An example of this being used was to find the sun's composition. We know now through using a spectroscope, which is how you can see these lines and the absorption spectrum, that the sun is mainly made of mainly hydrogen and helium. This spectrum also has many other uses, such as telling if a galaxy is moving towards you or away from you. The colors either shift to the red side, which is called red shifting, or the blue side, which is blue shifting. The reason the colors change is because the wavelengths differ depending on how close it is to you. And because each color has a different wavelength, that means the absorbed lines will change. So now here's my bibliography or my works cited, and thank you for watching my presentation.